Alright, today we're going to be talking about segment lengths and circles. Our objective is that we will be able to find the lengths of segments of chords, tangents, and secants. So let's review some vocabulary first. Remember that a secant line or a secant line segment, such as PQ, passes through 2 points on the circle. A tangent line only touches 1 point on the circle. So it would be like SP. So some rules. If we have two chords intersecting, like CD and AB do, our rule is that each piece from the outside to the intersection, so A to E, B to E, D to E, and C to E are going to be used. The pieces that come from the same segment get multiplied. So AE times BE will equal CE times DE. So the pieces from the same segment get multiplied, and they'll be equal to the pieces of the other segment multiplied. So here, A to E is X times B to E is 4 will equal C to E is 3 times E to D is 8. So we would have 4x equals 24. Divide both sides by 4 and we get that x equals 6. This one doesn't have any variables or any points labeled on it, but we know the ones that come from the same segment are going to be the ones that get multiplied. So we'll have x times x equals 4 times 9. X times x is x squared. 4 times 9 is 36. To undo the square, we're going to square root both sides. And technically, when you square root both sides, you would have plus or minus here. However, we can't have a negative length for a segment, so we're just going to say x equals 6. So this is when they're intersecting inside. If they're intersecting outside, like here they intersect at point E, we're still going to use from each outside point to the intersection point for our equation. So we're still going to do A to E times B to E, but be careful, we're going B all the way to E. So from B all the way to E. So it's this whole thing is BE. It's the entire thing. Equals C to E and times D to E. So again, it's this whole thing for D to E. So C to E times D to E. So if you look at both of those, every single segment that we're using includes the point where they intersect, whether it's inside or outside. The other way you can remember this is A to E is our outside piece times the entire thing, the entire segment. And then again, it's the outside piece times the entire thing. So here, we're going to start with this segment at the top. The outside is 4. Now be careful, the entire thing is all the way from here to here, which is 10, equals the outside, which is 5, times the entire thing is 5 and x, which would be x plus 5. Four times 10 is 40. Here we'll need to distribute the 5, and we'll get 5x plus 25. Subtract 25, we get 15 equals 5x. And if we divide both sides by 5, we get that x equals 3. This one, I'm just going to start off by finding our entire segments before we start. The entire thing here is 9. Here, the entire thing, x plus x would be 2x. So outside is 3 times the entire thing is 9 equals outside, which is x, times the entire thing, which is 2x. 3 times 9 is 27. X times 2x is going to be 2x squared. To get rid of, or before we can get rid of the squared, we need to get rid of the 2. So we get that x squared equals 13.5. And it's okay to leave it as a decimal when it's a short decimal. If it's a decimal that goes on forever, I would leave it in fraction form. And then square root both sides. And we get that x is approximately 3.7. And our last segments are going to deal with one secant and one tangent. So A to E is both our outside piece and it's the entire thing. So we're going to use it twice. AE times AE. And then for our secant, it's still going to be the points on the circle to the intersection point. So C to E times D to E. So since outside and the entire thing are the same for the tangent line, entire times entire equals the outside times the entire. So here we have the outside for the outside and the entire for the tangent line. We have the outside for the secant line, and it told us already that the whole thing is 16. So entire times entire for the tangent line equals outside times the entire secant line. So we get 144 equals 16x. Divide both sides by 16, and we get that x equals 9. This one didn't give us the entire for the secant line, so let's calculate that real quick. The whole thing would be 13. So we're going to have 2x times 2x, entire times entire, equals outside, which is 9, times the entire, which is 13. 2x times 2x will give us 4x squared equals 117. Divide by 4, we get x squared equals 29.25. Then we'll square root both sides, and we get that x is approximately 5.4. Finally, for your summary, how are all the formulas related? That's all for today. See you in class.